Look back at everything we've explored so far. We've witnessed the violent birth of stars, the majestic dance of galaxies, and the invisible grip of gravity. We have seen a universe that is vibrant, energetic, and seemingly eternal. But the laws of physics tell a different story. Just as every star must eventually exhaust its fuel and every living thing must face its end, the universe itself is traveling toward a final destination. We are living in the stelliferous era, a brief, bright flash of light in the infinite timeline of the cosmos. But what happens when the lights go out? Will the universe collapse in a fiery finale, tear itself apart in a violent frenzy, or simply fade away into a cold, eternal silence? Today, we peer into the ultimate crystal ball to explore the three possible endings of everything: the heat death, the big crunch, and the big rip. To understand the end, we must first look at the force that is driving the universe toward its destiny: expansion. In the 1920s, Edwin Hubble discovered that galaxies are moving away from us and from each other. But in the late 1990s, we discovered something even more shocking. The expansion isn't slowing down under the weight of gravity. It is accelerating. This acceleration is caused by a mysterious, invisible force called dark energy. This cosmic anti-gravity makes up about 68% of the universe, and it is the primary judge, jury, and executioner of our cosmic future. The first, and currently most scientifically accepted theory, is the heat death also known as the Big Freeze. This is the whimper rather than the bang. In this scenario, dark energy continues to push galaxies apart forever. As the universe expands, matter becomes more and more spread out. Stars will continue to be born in nebulae, but eventually the gas reservoirs will run dry. One by one, the stars will blink out. The red dwarfs, the longest living stars, will finally exhaust their fuel after trillions of years, leaving the universe in a state of perpetual twilight. But the decay doesn't stop there. Over vast eons of time, even the dead remnants, the black holes, will begin to evaporate through a process called Hawking radiation. Eventually, even atoms might decay. The universe will become a vast, cold, and empty void, where the temperature sits just a fraction above absolute zero. At this point, entropy, the measure of disorder, reaches its maximum. No more energy can be transferred, meaning no more work can be performed. No light, no heat, no life. Time itself becomes meaningless because nothing ever happens anymore. It is a state of perfect, eternal equilibrium. The universe doesn't disappear. It just becomes a graveyard of frozen photons stretched across an infinite nothingness. The second possibility is the big crunch . This is the favorite of those who love symmetry. It assumes that at some point in the future, the density of matter in the universe will overcome the outward push of dark energy. Gravity would finally win the tug-of-war. The expansion would slow down, stop, and then reverse. Galaxies would begin to hurtle toward each other. At first, this would be an astronomer's dream, as distant galaxies become visible and blue shifted as they approach. But as the universe shrinks, the radiation that was stretched out during expansion begins to compress and heat up. The cosmic microwave background radiation would rise from a few degrees above absolute zero to thousands of degrees. The sky would grow hotter than the surface of a star. In the final moments, galaxies would merge, stars would collide, and all matter would be crushed back into a high-density, high-temperature singularity, exactly like the Big Bang, but in reverse. Some scientists speculate this could lead to a big bounce, where the singularity explodes again in a new Big Bang, creating a cyclical universe that breathes in and out forever. The third and perhaps most terrifying scenario is the big rip asterisk. This happens if the strength of dark energy isn't constant, but actually increases over time. If dark energy becomes phantom energy, its repulsive force will eventually become stronger than all other forces of nature. First, it will overcome the gravity holding clusters of galaxies together, sending them flying off into the void. Then it will tear galaxies themselves apart, stripping stars away from their orbits. As the rip accelerates, the force becomes strong enough to overcome the gravity holding planets to stars. The Earth would be torn away from the Sun, and then the Earth itself would be shattered. In the final microscopic fractions of a second, the force would become so intense that it would overcome the electromagnetic and nuclear forces. Atoms would be ripped apart, and then the fabric of space-time itself would be shredded. The universe would literally cease to exist as a physical entity, dissolved into a chaotic soup of disconnected particles. Which of these fates awaits us? The answer lies in the cosmic density parameter and the nature of dark energy. If the web of the universe is flat, as our current measurements suggest, the heat death is the most likely outcome. We appear to be living in a Goldilocks universe that is destined to expand forever, but not so fast that it rips apart immediately. However, our understanding of dark energy is still in its infancy. If its strength changes even slightly over the next few billion years, the Big Rip or the Big Crunch could suddenly become the leading contenders. There is also a fourth, more exotic possibility. Vacuum decay Quantum physics suggests that our universe might be in what's called a false vacuum, a state that is stable, but not the most stable possible. If a bubble of a lower energy state were to form anywhere in the universe, it would expand at the speed of light, incinerating and rewriting the laws of physics as it passes. We wouldn't see it coming. We would simply cease to exist in an instant. It would be the ultimate reset button for the cosmos. These timelines are unimaginably long. The heat death wouldn't be complete for years, a number so large that if you wrote a 0 on every atom in the observable universe, you still wouldn't have enough atoms to finish the number. In contrast, the human race has only existed for a few 100,000 years. We are witnessing the very first seconds of a cosmic play that will last for an eternity. Does the eventual end of the universe make our lives meaningless? On the contrary, many philosophers and scientists argue it makes our existence more significant. We are living during the springtime of the universe. We exist at a time when the stars are still bright, the galaxies are still close enough to see, and the conditions for life are perfect. We are the universe's way of witnessing its own glory before the long winter sets in. Our ability to sit here on a tiny planet and use math and logic to predict the end of time itself is a testament to the power of consciousness. The future of the universe is a story of transition. It is the story of energy spreading out, of complexity fading into simplicity, and of the ultimate triumph of the laws of thermodynamics. But it also reminds us of the incredible journey we are part of. From a single point of infinite heat to a near infinite expanse of cold, the universe is a masterpiece of change. As we look out at the night sky, we see a universe that is full of life and light. But we must also acknowledge the shadows. The same forces that gave us birth are the ones that will eventually lead us to the end. But that end is so far away that it is effectively infinite. We have billions of years to explore, to learn, and to perhaps even find a way to survive the cooling of the stars. Thank you for joining us for this final epic chapter in our journey through the cosmos. We have traveled from the hearts of stars to the edge of the void, and we have seen that the universe is far stranger and more beautiful than we ever could have imagined. If you've enjoyed this series on the wonders of the universe, make sure to subscribe and stay tuned. We have many more mysteries to explore, from the quantum world to the possibilities of the multiverse. Until next time, cherish the light while it lasts. Keep your eyes on the horizon, and never stop wondering about the ultimate fate of the stars. Safe travels through the infinity of time.